Hello and welcome. Integration, integrating sine to the power of 5 and cos to the power of 5. How do we do this particular integrals? Well, I've done the sine cubed and the cos cubed the other day, so they work in analogy. There are two methods. One method is, of course, by using a substitution. The other one is by using some kind of manipulation. I'm going to use the substitution method first for, let's say, for the sine to the 5 first of all, and then we'll do the manipulation, let's say, for the cos. Okay, this is how it works. So we're trying to integrate sine to the power of 5 of x dx. What substitution do we use for something like that is the next question. If we have to integrate sine to the 5, the substitution that we use is u is equal to cos of x. The same way if we had cos to the 5 of x, we'll be using u is equal to sine of x. It works exactly the same way as the sine cubed and cos cubed. So let's proceed with the substitution. Differentiate it, du by dx is equal to negative sine x, and rearrange to make dx the subject. So dx on this side will give us du over negative sine of x. What happens next? We're going to put it into our integral. Here it goes. Sine to the 5 will leave him as he is at the moment. The dx is this quantity here, so times du over negative sine of x. Cancellations will take place. Gone, and this will go now to the power of 4. And let's do a little bit of a tidy. Let's not forget the negative from there, so minus, and then we have a sine to the 4 of x du. Careful, because the variables do not match. We're having, with respect to u, integration, but the variable is still in x. How are we going to do this one? Of course, we can actually swap into cos squared by using the identity. Let me just write it here. Do I have enough space perhaps to do it there? Yeah, just about probably. So if I bunch it up a little bit, minus. Now I'm going to do an extra line. So I'm going to write this as sine squared of x, okay, and all squared du still. So now this will become minus, that's the minus there. Now in the bracket, I'm going to write 1 minus the cos of squared of x all squared, still du. We need to multiply it out. So careful with the signs there so we don't make mistakes. Minus, squaring this bracket, 1 minus 2 cos squared of x plus cos to the 4 of x. If you do not feel confident to square it on the spot, please put two brackets, some on the side here, multiply them. Don't forget that minus obviously when you come back to put your stuff. So one more thing, remove now the bracket here. So it's going to give us a minus 1 plus 2 cos squared of x minus cos to the 4 of x du still. Let's draw a line there. But now, of course, we switched everything into coses, and that's now my u. So negative 1 plus 2 cos squared can be replaced now for u squared, and is minus u to the 4. That's the cos to the 4. But now we're in u. And therefore we're done now because this will integrate instantly to a minus u plus 2/3 u cubed minus 1/5 u to the 5 plus a constant. And the last thing we need to do is to finally put our substitution in. I'm just going to make a little bit of space because I don't want to write it on the next line. So it's going to be a minus cos x plus 2/3 cos cubed of x minus 1/5. It doesn't look like I'm going to make it. I'm going to actually bend it around. I think you'll let me. Cos to the 5 of x plus c. That's the best I can do. Okay, so that's the sine to the 5 of x done. I'm also going to do the corresponding one, but for a cos. But this one, I'm not going to do it by substitution. I'm going to do it by manipulation. So here it is, cos to the 5 of x dx. If I was to use a substitution, the substitution, remember, is u is equal to sine x this time, but I'm not going to. What I'm going to do instead is I'm going to write it as a cos of x multiplying a cos to the 4 of x dx. My intention is to change this quantity to a function of sine, and this will be the derivative of the sine. So this is what the substitution did for us up there. So the cos of x, I will leave it, and the cos to the 4, I'm going to write it as 1 minus sine squared. That's the cos squared, but because to the 4, it needs to be squared again. Just check that I've done it correctly. There's my cos squared in there. All squared is the cos to the 4. And now, of course, it's at the front, dx. All I'm doing next is I'm going to square this expression out because I'm going to actually have a crash here with this thing here. Let me just go to the next line and go about here. So that is equal to cos of x, multiply the bracket, again, 1 minus 2 sine squared x plus, I'm writing stupidly cos there, plus sine to the 4 of x dx. Again, if you cannot see where these bits are coming from, just multiply 2 brackets. And now we can either leave it like that and integrate, but probably it's better if we multiply it out term by term. So that's the cos of x minus 2 sine squared of x cos of x plus sine to the 4 of x cos x dx. Now all of this now are integrable because of course the first one is not difficult. It's of course comes from differentiating a sine. Sine differentiates to a plus, and that's all good. There's nothing to do. There's no change or anything like that. This is now the tricky bit which we need to recognize. Because we have a power of sine and the cos of x next to it, which is its derivative, that starts at the higher power of sine. So a sine cubed was differentiated. So when we differentiate that, a 3 will come to the front. The sine of sine cubed will go to sine squared, and then it will produce times a cos of x. So we have everything except that 3. So we need to get rid of this 3. So minus 2 divided by 3 by recognition. And finally, by the same argument, we got a sine to the 4, and next to it we got cos of x, which is the derivative of the sine. So it starts at the higher power, sine to the power of 5 of x. When we differentiate it, we'll get that, but we'll also get a 5 at the front. So in order to get rid of the 5, we put a fifth plus c, and this is how we integrating the powers of 5 of sine and cos, and of course this is the end. I hope you find it useful, and I'll see you very soon.